Hey guys, welcome back. Let me walk you through a scenario that might sound familiar. Imagine a growing company that needs to train new employees, support customers, or help internal teams quickly find answers about policies, procedures, or product features. Or you're visiting a travel website, and instead of digging through pages of info, you can just ask a chatbot questions like, "Do I lose access?" right after I cancel. And it instantly answers, straight from the company's official docs. In this video, I'll show you step by step how to make this chatbot production ready and integrate it into any website like this one. Before we jump into the setup, quick heads up. If you're into building with n8n, AI agents, or automation tools, you'll definitely want to check out my 0 to Launch community. It's a free space I built on School for people who want to go from zero to launching real automations. Whether you're just starting or already building advanced workflows, you'll get step-by-step AI automation tutorials, pre-built templates from videos like this one, and real support from real builders. Plus, every resource I mention in this video, including the scripts, links, and tools, will be posted directly inside the community. Come introduce yourself, ask questions, and grab the tools you need to build smarter and faster. Links in the description. All right, back to the setup. Normally, that would require someone who's already familiar with the internal documentation, maybe a senior staff member, a manager, or a live chat support agent. But here's the problem that takes time, money, and a lot of manual effort. And as the business grows, that knowledge gap grows with it, making it harder and harder to handle everything manually. That's where AI can make a big impact. What if you could build a chatbot that acts like a professional trainer or support agent? Someone who's read all your documentation and can respond to questions naturally, anytime, 24/7. Well, in this video, that's exactly what we're going to build. But before we dive in, let's make sure your n8n instance is ready to go. Whether you're using the cloud version, running it locally, or hosting it on a VPS, the steps in this video will apply to all setups. Before we dive into building it step by step, let's explore the tech behind the scenes. We're going to break down everything you need to know about how this works. So whether you're technical or not, it'll all make sense. This isn't just about copying steps. It's about actually understanding what's happening, so you're not just running commands like a machine, but building like a real automation architect. So how do we actually make this kind of smart assistant a reality? One that doesn't just spit out generic answers, but gives real useful responses based on your company's own documentation. To do that, we need to combine two powerful things: your data like training manuals, policy docs, or product FAQs, and a language model like ChatGPT or Claude. But here's the key. We don't just throw your documents into the AI and hope for the best. Even though AI models are smart, they're not magic. They can't just take a huge document, instantly understand it, and remember it forever like a human would. Language models like ChatGPT don't work like humans. They can't just read a full document and remember it forever. Models can only handle a limited amount of text at once. It can't scroll or browse through files. It only sees what you give it right now. So what's the solution? This is where RAG comes in. RAG stands for Retrieval-Augmented Generation, and it acts as the bridge between your unstructured data and the LLM. LLMs, like ChatGPT, aren't built to read through entire files or documents. They work best when you feed them just the right information, in a clean, structured format. So with RAG, we handle all the prep work before the LLM sees anything. That means taking your messy, unstructured documents and transforming them into something the AI can actually understand. Let's just start with the first step in that transformation: splitting your document into smaller, searchable chunks. Think of it like turning a textbook into flashcards. You can't memorize the whole book, but if you organize the key ideas, you can pull up the right info exactly when you need it. This is the first step toward making your documents AI readable and searchable. Now that we've split your documents into smaller chunks, the next challenge is, how do we search those chunks? Not just by exact words, but by what they mean. Why keyword search isn't enough. Let's use an example. Imagine you're on Netflix, and you want to find a movie, but you don't remember the title. You type something like that sci-fi movie where the guy wakes up over and over again on the battlefield. If Netflix only used keyword search, it would try to match your words exactly. So unless you type the exact title, you'd get nothing. But what you're really doing is describing the meaning or concept behind the movie. That's what most real-world questions are like, especially when people use natural language. What's the refund policy for annual subscribers? How do I reset a user's password? These kinds of questions are not easy to answer with keyword matches. They're too human, too nuanced. The solution: search by meaning instead of words. And that's where embeddings come in. Embeddings are a way to translate a chunk of text into a vector, a list of numbers that represents the meaning of that text. Then when someone asks a question, we also turn that question into a vector. And now instead of doing a simple word match, we can compare the two vectors mathematically to see which document chunks are most semantically related to the question. This lets the agent find and use the right context, not just guess. In short, embeddings turn your text into math that captures meaning. This makes it possible for AI agent to compare, search, and retrieve the right answers based on what things mean, not just what they say. Now that every chunk of your document is turned into a vector, we need a smart place to store and search them. That's where a vector database comes in. What is a vector database? It's a special kind of database designed to store embeddings and quickly find the ones that are most similar to a new input. Let's say someone asks, how do I update my billing info? We convert that question into a vector. Then we ask the database, which chunks of our documents have a vector closest to this one? The database compares how close the meaning is and returns the most relevant matches, even if they use totally different words. To compare meaning, it uses math, specifically something called cosine similarity. If two vectors point in almost the same direction, that means they're very similar. But if they point in opposite directions, they're not related at all. This lets the LLM like OpenAI chat model match questions to the right answers in your data based on meaning, not just keywords. So now we know how vectors work and how we compare them based on meaning, not just words. Here's the next step. We need a place to store those vectors and search them in real time when someone asks a question. There are several great services that provide vector storage and search capabilities. In this tutorial, we'll be using Pinecone for a few key reasons. It's cloud-hosted. No server setup required. It has a generous free tier, perfect for testing and small projects. And it integrates easily with tools like OpenAI and n8n. All we need is a free Pinecone account and an API key, and we're ready to store and search vectors in real time. Now that we have broken down each piece from document chunks to embeddings to semantic search, let's look at how it all works together behind the scenes. This is the full RAG loop, short for Retrieval-Augmented Generation in action. First, we take your document and split it into smaller chunks, like paragraphs or sections. Then we use OpenAI's text embedding API to convert each chunk into a vector, a math-based representation of its meaning. Those vectors are stored in a vector database, like Pinecone. Now, when a user asks a question, for example, how do I change my billing method? That question is also converted into a vector using the same embedding model. That vector is then sent to Pinecone, which compares it to all your stored document chunk vectors. Using cosine similarity, it finds the chunks with the closest meaning, even if the wording is totally different. Those relevant chunks, along with the original question, are passed to a language model, like GPT-4 or Claude. Finally, the model generates a smart, helpful answer in natural language based on your data, not just guesses from general training. Now, let's make this real. To build this system, we first need a vector database to store our content. All right, let's set up our vector database using Pinecone. Head over to pinecone.io, click Sign Up and create your account. Once you're in, you'll see your API key, copy it, and save them somewhere safe on your machine. You'll need it when we connect Pinecone to n8n. Next, we need to create a new index. This is your actual vector database. Give it a clear name like knowledge base or chatbot RAG. Then choose your embedding model. For this demo, we'll keep it simple and select OpenAI text embeddings, small model. So what's the difference between small and large embeddings? It comes down to dimensions. When we say dimensions, we're talking about the number of values in each embedding vector. Each dimension is like a feature or coordinate that helps represent the meaning of the text. Higher dimensions can capture more detail and nuance, but they take more space and more time to search. For now, small is fast, free, and great for most use cases. Now let's talk about metrics, how Pinecone compares vectors to find the best match. By default, we use cosine similarity, the method we just explored a moment ago. It compares the angle between two vectors, and if they point in a similar direction, it means they carry similar meaning. There are other metric options too, like dot product is like multiplying two vectors together. A higher dot product between the query vector and a document vector means they point in a similar direction. So the query and document are likely related in meaning. It gives a higher score when both vectors have similar values in the same places. Dot product is useful in many machine learning applications, especially when the magnitude of vectors carries meaning. But for semantic search, cosine similarity is the most commonly used method. So why is cosine similarity the most commonly used method in semantic search? It comes down to what we care about in a chatbot or RAG system. Semantic, meaning not the length of the text. When we embed a document, whether it's a sentence or an entire page, that vector carries two things. One, its direction, which captures the meaning. Two, its length, which reflects how strong or confident that representation might be. Cosine similarity focuses only on the direction of vectors. It measures the angle between them. So even if two vectors are different lengths, if they point in the same direction, they represent similar meaning. In embeddings, that direction is what carries semantic information, which is exactly what we need when matching questions to answers. On the other hand, dot product takes both direction and length into account. That can be helpful when magnitude matters, like in certain ranking models or confidence scoring systems. But for comparing pure meaning, we usually don't care how strong or long a vector is. We just care if it's pointing to the same idea. That's why cosine similarity is preferred for matching questions to answers, finding related chunks of text, and building RAG or semantic search systems. It gives us comparisons based on meaning without being skewed by vector size. So now we know why cosine similarity is the go-to for semantic search. With that set, we're almost done setting up our vector database. Next, choose a cloud provider. Choose any option is fine here for testing. Then pick a region close to your app or user base. For this tutorial, we'll stick with the free tier. That's the starter plan. Then click Create Index. Just like that. You've successfully created your vector database. Right now, it's still empty. But in the next step, we'll use n8n to send data into this index. All right, let's head back to n8n. Before we build the full workflow, we need to prepare the document we want to process. In this example, I've already uploaded a document to Google Drive. You can do the same. Just make sure it's accessible from your account. Next, we need to connect n8n to Google Drive, so it can pull in the document automatically. To do that, we'll create a Google Client ID and client secret from the Google Cloud Console. These credentials let n8n authenticate with your Google account and securely access your Drive data, like downloading files into the workflow. Head over to Google Cloud and log into your account. If you don't already have a project, click Create Project and give it a name, then hit Create button. Then go to your project's dashboard and open APIs and Services. Click Enable APIs and Services. Search for Google Drive API. Click it and hit Enable. Once the Google Drive API is enabled, we're ready to generate the credentials that n8n will use to connect. The access type should be user data. All right, hit Next. Now you'll name your app and fill in your developer and support email. Click Save and Continue. Save and continue again. Now we'll create the actual credentials. Choose Web Application as the app type, give it a name like Chatbot RAG. You'll see fields for authorized JavaScript origins, authorized redirect URIs. We'll leave these blank for now because we'll get that redirect URL from n8n in a moment. Click Create. Now you'll see your new client ID. Click Done to finish setup. Next, go to the Credentials tab. You'll see your new web application listed with its client ID. Click the Edit icon to open it. Here, you'll find both your client ID and client secret. These are the credentials we'll use in our n8n workflow to authenticate with your Google account. All right, let's head over to n8n. Log into your account and create a new workflow. Give it a clear, meaningful name. Start by adding a manual trigger node. This lets you run the workflow with a single click while testing. Then add a Google Drive node as the next step. Set the action to download file, since we want to pull a document from your Google Drive. To connect Google Drive, we'll need to authenticate this node. It'll show a redirect URL. Copy this URL and paste it back into your Google Cloud App settings under Authorized Redirect URIs. Now, paste your client ID and client secret into the authentication fields. Before clicking Sign in with Google, we need to push the app to production to avoid access errors. In the Audience tab, click Publish App. Now return to n8n and click Sign in with Google. Select the same Google account used to create the credentials. You'll get a warning, but that's okay. This is your private n8n setup. Allow full access to your Google Drive files and hit Continue. And just like that, you're connected. You should now see your Google Drive files listed in n8n. All right, let's select this file. This is the exact document we stored earlier on Google Drive. All right, to keep things simple, we'll use the Pull by URL option here. It will automatically switch to the document URL field. We've got our file selected and everything is connected: credentials, access, and the node setup. Now let's test the workflow to make sure we can download the document from Google Drive successfully. Click Execute Node or Test Workflow and watch n8n pull in the file. And just like that, we've downloaded a file directly from Google Drive. Now we're ready to process and store that document in our vector database, Pinecone. Let's add a new node to the workflow. Select the Pinecone Vector Store node. Set the action to Add Document to Vector Store. To connect to Pinecone, we first need to add a new credential. Here, we paste in your Pinecone API key, the one we saved earlier when we signed up. Once connected, you'll see the list of your indexes. Select the index you created earlier. You might see an error because this node also needs an embedding model to convert the text into vectors. We already selected OpenAI Text Embedding, small model, when we created the Pinecone index. So let's use the same model here. Again, we need to create a new credential. This time for the embedding node, grab your OpenAI API key and paste it here to connect to your OpenAI account. Then hit Save. We leave the embedding model as the default text embedding small, the same model we selected earlier when creating the index in Pinecone. This keeps everything consistent between n8n, OpenAI, and Pinecone, and ensures that everything is aligned and works perfectly. Before we run the OpenAI embeddings node to convert our file into vectors, we need to tell n8n how to load the document data. This step is required by the Pinecone Vector Store node. So let's add a document loaders node. You'll see two options. Since we're not loading anything from GitHub, we'll stick with the default file loader. Our file is a doc file stored as binary, so under data type, select binary. We'll keep the default settings, load all input data, auto-detect the file format, which is great for handling different doc types automatically. Okay, now here comes a really important part. We need to split the text into smaller chunks before sending it to the embedding model. Why do we split the text? Because AI models like GPT can't process huge blocks of text all at once. Think of it like flashcards. You break a big book into smaller pieces, so the AI can understand one piece at a time and still keep the meaning clear. This is handled by something called a text splitter. You'll see 3 types, but for this tutorial, we'll choose the recursive character text splitter. What's a recursive splitter? Don't worry, it sounds complex, but here's what it really means. It tries to split the text at natural points, like paragraphs, sentences, or even spaces. Instead of cutting things off in the middle of a thought, if it can't find a paragraph, it looks for a sentence. If no sentence, it looks for a word. That's what recursive means. It works from big chunks down to smaller ones. It's the most recommended option when your text varies in length and structure, like documents, articles, or support manuals. So we've selected the recursive character text splitter. Now let's move on to the next part, setting the chunk size and chunk overlap. 2 key settings that control how the document gets broken down. What is chunk size, and why does it matter? This specifies the target length for each chunk. When we split a document for AI processing, we break it into smaller parts called chunks, kind of like dividing a long book into flashcards. The chunk size controls how big each flashcard is, measured in characters, not words. For example, a chunk size of 1000 means each chunk will contain about 1 long paragraph or a few short ones, roughly 150 to 200 words. Why that number? Because large language models like GPT have a limit on how much they can see at once. This is called the context window. If we send chunks that are too big, we may hit token limits, losing performance or skipping important content. But here's the clever part. If the chunk is still too long, the splitter will call itself again, recursively, to break that big piece into smaller ones. This is what makes it different from basic splitting methods. The recursive splitter is smart. It keeps trying to split content in a way that preserves meaning and flow without cutting sentences or ideas in half. So in simple terms, if the content fits inside the chunk size, it's great. Keep it as is. If it's too long, split it again until it fits. Repeat this process recursively until every chunk is clean and manageable. But if we send chunks that are too small, the AI might miss the context of the message. That's why the default 1000 characters works great for most documents. Next is chunk overlap. Now you might be wondering, why would we want chunks to overlap at all? Well, here's the deal. When we split a document into chunks, sometimes a sentence or important idea ends up right at the edge, cut off between 2 chunks. That's a problem, because the AI might not get the full meaning if half the sentence is missing, so instead, we add a little overlap between chunks, like having the last bit of one chunk repeated at the start of the next. This keeps the context flowing smoothly and makes sure nothing important gets lost during the split. Why 200? 200 characters is about 1 to 2 sentences. That's usually enough to carry over full thoughts, transitions, or headers that might otherwise be cut off. It's a great starting point, especially for longer paragraphs or structured docs. Now that we've configured the chunk size and overlap, our document is fully prepped and ready to be embedded. The next step is to test the workflow and watch it convert our document into vector format using OpenAI embeddings. Then push that data into our Pinecone index. Click Execute Workflow or Test, and n8n will run the full flow, from loading the file to splitting it, embedding it, and sending it to Pinecone. Once it finishes, let's head back to our Pinecone dashboard and open the index we created earlier. Inside, you'll now see a list of vector entries, each one representing a chunk of your original document. You've now seen the full pipeline in action. The document was split into chunks. Each chunk was embedded into a vector, then stored inside Pinecone, your vector database. Through this process, the meaning was preserved, and now your content is fully searchable and ready to power your RAG system. With everything set up, we're ready to build the actual chatbot workflow, where users can ask questions and get answers. Now let's head back to n8n and start building our chatbot workflow. The part that talks to users will start by adding a chat trigger node. This listens for incoming user input like a message in a web chat or API request. But here's something important to keep in mind. We only need to process and embed our document once. Since all the vectors are already saved in Pinecone, there's no need to re-upload or reprocess the file every time the chatbot runs. To avoid duplicating data, make sure to keep your chatbot logic separate from the document processing workflow. You can either create a new workflow just for the chatbot or build the chat flow in a separate path from your existing nodes. This way, the chatbot only talks to Pinecone, where your document vectors are already stored and ready to use. This chatbot will be built around a Q&A flow. The user asks a question and the system returns a smart, human-like answer. So next, let's add the question and answer chain node. This node handles the logic of pulling relevant context and generating a response. For this tutorial, we'll use OpenAI's chat model as our LLM, but you can swap in any language model you have access to, like Claude, Cohere, or even a self-hosted LLM. Just make sure to connect your OpenAI account by pasting in your API key as a credential. Now that our chat OpenAI node is ready and connected, let's complete the rest of the Q&A pipeline. Next, the question and answer chain requires a retriever node. This is what actually connects to our stored vector data. So let's add a vector store retriever node. Inside this node, we'll keep the limit parameter set to the default. That means when the user asks a question, the system will return the top 4 most relevant chunks from Pinecone, based on meaning, not just keywords, or in simply term, this is the maximum number of results to return. Then we specify which vector store we want to use, and in our case, that's the Pinecone vector store we set up earlier. Again, make sure to use the same credentials you created before. So the retriever has access to your index and all the embedded document data. Pinecone also needs to know which embedding model you use to create those vectors. So here, we select OpenAI's text embedding small to match what we used when we uploaded the document to Pinecone. Keeping the embedding model consistent is critical. It ensures that your question vector and your document vectors speak the same language. This part of the workflow may look similar to when we first processed the document, but now we're doing something very different. We're not uploading any files or converting new data. Instead, here's what's happening. The user's question is first converted into a vector. That vector is sent to Pinecone, which searches your document index for the most relevant chunks. Those chunks are passed to the LLM, which uses them as context to generate a smart, natural response. And just like that, we've successfully built a simple yet powerful RAG system. Now let's test the chatbot in action. We'll start by asking a question based on the document content, and boom, we get a response that pulls the exact information we embedded earlier. Before we test the next question, let's scroll down to the data privacy section in the document to see what kind of info we expect the chatbot to retrieve. Here it is. It mentions that user data is encrypted, and for any privacy inquiries, there's a contact email listed right here. So let's try asking the chatbot and see if it can retrieve that exact detail from the document. This time we're testing if the AI can pull the contact email from the data privacy section of the document, and yep, it nails it. We get the exact answer from that section. Now let's push this chatbot to production mode, so anyone can access it 24/7 and ask questions from your document. To do that, we go back to the chat trigger node and enable the toggle to make it public. This gives us a webhook URL that will listen for user input and respond in real time. But to actually go live, we also need to activate the workflow. So let's toggle the workflow itself, and it's now live. Now, refresh the public webhook URL, and you'll see the interface for your chatbot. Let's ask it a quick question again. And just like before, it responds perfectly, pulling data directly from your document. One thing you might notice, right now the chatbot's answer includes the word response in front of the text. It works, but it doesn't look very friendly. Let's clean that up using a code node. This node will run right after the question and answer chain, and we'll use a bit of Python to clean up the output. n8n gives us a built-in variable called input, which holds a list of response objects in JSON format. Right now, it includes key value pairs like response and its text. To fix that, we'll create a new variable called results and extract only the raw text from each item. We loops through each item in input, accesses the result with item.json.response, then adds that to a new list of clean text only. Finally, we returns that list as results. Now let's run the workflow again and check out how the response looks. And now, the chatbot responds with a clean, friendly message, no extra keys. Before you go live, don't forget to save your workflow so everything stays active when users interact with the public chatbot. Let's do one final test. Ask a question and make sure the chatbot responds with a clean, readable answer. Looks great. Everything's working as expected. Now, let's personalize the chatbot's initial greeting. Go back to the chat trigger node and scroll to the initial message section. For this tutorial, we'll also leave authentication turned off so that anyone can access the bot freely. Here, you can change the welcome message to anything you like. Hit save. Refresh the chatbot page. Just like that. Your chatbot is now live, and it greets users with your very own custom welcome message. It's the perfect first impression for anyone asking questions. That's it. A fully working, document-aware AI chatbot powered by n8n, Pinecone, and OpenAI, live and ready for real users. But before we wrap up, I've got a special bonus for you, something that most tutorials don't show. Let me walk you through how to make your chatbot production-ready and embed it directly into any website, just like the travel site I showed you at the beginning of this video. I've already prepared a sample HTML landing page. This is a simple homepage layout that we can use as a starting point. If you have your own website, just open your main HTML file like this. The next step is to embed the chatbot in the bottom right corner of the page. To do that, first, add the n8n chat styling CDN inside the head tag of your HTML page. Next, add a script tag at the bottom of your page. This loads the chatbot widget and connects it to the webhook URL from your live chat trigger in n8n. And remember, this webhook URL should be the same one used in your chat trigger node inside n8n. Under trigger mode, change it from hosted chat to embedded widget. This tells n8n to serve the chatbot as a widget that can be embedded directly on your website, instead of opening in a separate page. Make sure to save your workflow in n8n so the new settings take effect. Then head back to your HTML script. Here's where you can customize the entire chat UI experience. You can edit everything from the initial welcome message, the chatbot title, a helpful subtitle, and the placeholder in the input field. Once you're done, save your HTML file, then refresh your web page, and just like that, your chatbot appears as a polished widget ready to chat right from your site. You'll see your custom title, subtitle, and placeholder text exactly as we configured it. Let's test it by asking a real question. And just like before, the bot pulls the answer straight from your documentation. And that's it. You've now built a fully working RAG-powered AI chatbot, connected it to your docs, deployed it, and embedded it into a real website. If this video helped you, give it a like. Subscribe for more tutorials on AI agents, automation, and self-hosted tools. And drop a comment if you have questions or want help with your setup. And don't forget, All the resources, scripts, and help are waiting for you in the 02 launch community on School. Join for free and start building with us. Until next time, build smart, automate better, and I'll see you in the next one.